Hi friends, I am Joyce and this is my channel where we explore the basic building blocks that are used to develop modern web applications. Today's topic is rate limiting, so let's dive in. Before we begin explaining what rate limiting is, let us see a short demo about a system that does not use rate limiting. Let us see what happens to this system when it gets bombarded with a lot of input. Here you see a very simplified version of a standard web application, which has multiple instances of application servers. They are sitting behind a load balancer, and this load balancer is getting a lot of requests from clients. This load balancer also evenly distributes the requests among the app servers. The application servers are green right now because the number of requests they are receiving is less than the maximum request rate that they support. Um, as long as this remains to be the case, it is fine. Whenever an application server receives requests that exceeds the maximum request rate for that application server, that app server will either become unresponsive or it would crash, forcing the load balancer to redistribute the requests among the remaining application servers. So this is the basic scenario that we have. Let us see what happens if we increase the number of input requests coming into the load balancer. So the requests have increased. You see the load on every server has also increased, but everything is within the limit right now. So no issues. What if we increase the request rate even further? Now you see the first server. The first server over here has exceeded its maximum rate and it has gone down. Load balancer redistributes. Even the second app server is now under a huge load. You can see it is going to go down now. All right, it went down. Now everything is going to the third server. Even though its maximum supported rate was high, it is not able to handle all these requests. Yep, even the third server went down. See what happened? All your application servers are down. Your load balancer cannot forward requests to any application server right now. So all the client requests, they're not receiving any responses. So your whole application has now become unresponsive. Not a very good scenario, right? So what is the solution for this? I guess you might have guessed right by now that one of the solutions for this scenario is to have a rate limiting service or a rate limiter. What does a rate limiter do? Well, in a nutshell, it what it does is it limits the maximum number of requests an application or any other server would process, and if the number of requests exceeds this limit, it will just simply reject those requests. What it so how does it help? It it helps by not overloading the application server and hence preventing it from crashing altogether. So you get a few rejects, but your application still stays up. Let us see that scenario next. Different organizations can have different strategies when it comes to rate limiting. Some may choose to not have any rate limiting at all, like the ones that you saw right now. Some may have a local rate limiting, which means that every application server instance has its own maximum rate set into it, and anything exceeding that gets rejected. Some organizations choose to have a central rate limiting service or a central rate limiting server which has a quota for the number of requests that can hit all the servers at a time. So these are these are the three basic ways you can divide rate limiting strategies. Let us start with local rate limiting and see how that behaves in response to a large number of input requests. Here we have the same setup again, but this time every application server has its own rate limiter. So if the number of requests exceeds the maximum rate that server supports, In that case, it will just start rejecting those requests. I'm going to increase the number of requests, and this will overload the first server on the top. And now, as you see, it has started rejecting those requests. So the status for this app server is red, but it has not yet gone down. The status for the second app server is orange. That means it is pretty close to its max. And the third one's healthy. Now, if we increase the input requests even further, even under this extremely large rate of input, the servers are holding up. Obviously, there are a lot of rejects, so a lot of requests are not getting any responses or are getting invalid responses. But the majority of the requests should get some response, and if say there are multiple requests from a particular user, at least some of them will get a response. So the application on the whole stays up, but uh, certain requests can get rejected. So this is what happens when you have a local rate limiter in place. Seems like a good way to implement rate limiting. What is the caveat? What is the limitation? Let us see that next.
So I've changed the scenario a bit. In the previous case, we had only one type of request. Now we have three types of requests: the payment request, the read request, and the write request. Also, these requests have different priorities. Payment requests have the highest priority because they represent a user trying to make a payment or trying to buy a service. Next comes write requests, and at the end lie the read requests. So in this system, if say at a particular point there is a peak in visitors and the number of read requests spikes by a lot. You see the orange balls over here, these are the read requests, and they have now started to swamp all the servers and hence causing a lot of rejects. But the interesting point here is that in the rejections, we don't just have the read requests, we also have the payment requests as well as the write requests getting rejected. But the traffic from the write request and the payment request is normal. It's not exceeding the limits, right? So this is really bad because now it is possible for users who are browsing the website to actually block a person who is trying to pay for your services. Not at all a good scenario. So how do you solve this? A quick fix would be to have request specific quotas. So we can have a separate limit for payment requests, separate for read requests, separate for write requests for every server separately. So this maximum limit for every server is now split into three parts, and hence the read request should not be able to uh, affect the payment request. But still, what happens, say, due to some reason, the payment service on the servers 2 and 3 go down. The load balancer would then be forced to send all the payment requests to the only server remaining, which is the first one. In that case, it is possible that in that server, the number of payment requests exceed the limit set for that server. But in fact, overall, the payment requests were the same. The key problem here is this app server is only able to see the requests that hit that particular server. It does not have the visibility of the total number of payment requests. If it had that, then it would have known that the total number of payment requests are still well within the the limit. So, so something else needs to be done. Something that allows for a total uptake of payment requests, whether or not all the servers are working. So, what could be the solution? Well, I guess you might have guessed by now. The solution was the next item in our list, which is a centralized rate limiting service. Let us take a look at that next. So here we have our web application with a centralized rate limiting service called rate quotas. This rate quotas service has configured three different rate limits for payment, write, and read. In this case, we have set all the three to 3000 respectively. Every app server continues to have its own maximum limit, which in this case is set to 4000 for all the three servers. And whenever a request is going to hit an app server, it will consult first its own local rate limiter, which will check for the max limit and see whether it has reached the max limit or not. If it satisfies, then it will consult the centralized rate quota service and ask whether the request for this request type have hit their max limit or not. If rate quotas confirms and allows, then and only then will the app server process that request. In other cases, the app server is going to reject that request. Let us see it in action. I'm going to increase the payment service by a little. I'm also going to increase the write request by a little, and I'm going to increase the read request by a lot. Now, payment and write overall should remain within their limits, but the read has exceeded its limit, which is reflected in the rate quotas. And hence, whatever is the excess amount is getting rejected. And the numbers that you see on the right are the ones that are getting processed. So over here, even though the read requests have the capability of swamping all the servers, they are not able to because they are getting rejected based on the quotas set in the rate quotas service. Now, if I increase the write service request also, in this case, even the writes will exceed their limit in the rate quotas and they will start getting rejected. But all through this, you will see that not even a single payment request is getting rejected because payment requests have not exceeded their limit. And this is exactly what we wanted. We wanted that one request of one particular service should not affect the request for other service types. And I think we have almost achieved that with us. We can achieve that with a centralized rate limiting service. Now, this approach is also not without its drawbacks. If you see here, every request made to the app server needs to consult the rate quotas. So now rate quotas becomes a kind of a bottleneck in our system, which is a con. But there are ways to mitigate this also. Now, we are not going to cover all of that in our current video. We may take that up later on. But for now, this is it for centralized rate limiting in a web application. Let us now go back to our original types of rate limiting strategies. So now we have come to the end of this video. Let us look back at the three types of rate limiting strategies that we had. First was to not have any rate limiting at all. So this is very easy to implement but has its drawbacks, as in it cannot prevent servers from crashing if there are a lot of requests coming in. So in order to fix this, we had the next strategy, which was local rate limiting, which performed quite well, even though it is a bit more complex to implement than having no rate limiting at all. It is able to prevent the servers from crashing, for one, and with some quick fixes like having different quotas for different request types, it can actually manage different scenarios pretty well. And most of the times, this may be all you need. But then, if you are running a very complex system and you want to precisely control the number of requests for every service type, then probably you should go with a centralized rate limiting strategy. Now, even this one has its drawbacks. Uh, Rate quotas service being a bottleneck was one that we discussed. Now, if you can mitigate these risks, then the pros outweigh the cons, then maybe centralized rate limiting strategy is the one you should select. So, in addition to all the rate limiting strategies that we have covered here, there is another side to rate limiting, which is the different ways in which you implement these strategies. And that is something that we'll cover in the next video in this series. So thank you all for going through this with me. I hope you found this video useful. If so, then please like and share and comment about what you liked and what you disliked. It will help me improve the videos going forward. Thanks and see you later.